SIMUL8 is the simulation tool of choice for the world's largest and innovative manufacturing organizations, including Ford, General Motors, Siemens, Cameron, and Kroger. Our vast manufacturing user base and experience with manufacturing users means we understand what is important for manufacturing engineers and the key stakeholders involved with process improvement. Let's look at an example. This simulation is set within an assembly line where multiple families of electric motors are produced. The purpose of this simulation is to see how we can increase the throughput of our current production line based on the production schedules feeding the line. As the model runs, you'll see different colored balls. These represent various products moving through the line. Time is shown on the clock and the number of finished goods is represented by the throughput number on the screen. Let's look at some of the inputs feeding the line. For the purpose of the simulation, we will change the production schedules and view the impact of increasing the demand. You can also change other variables using this interface, such as the processing times for the machines based on the product type. You can also control the changeover times for the different machines based on the product type in the system. Other inputs to the simulation are the line operators currently working within the system and responsible for specific areas. Let's run the simulation to the end and check out some of the results for the 4-week period. Moving the speed bar to full shows how fast you can get access to those all-important results. Now it's Friday, week 4. We can see the throughput of the system is 619 finished goods off of the line. To examine some of my results, the simulation is pre-populated with various KPIs. These are the important KPIs I want to report on. The types of measures available to analyze are things like units per hour, average time in the system, resource utilization including operators, and utilization of equipment. So, this brings us on to some what-if analysis. I want to change the input schedule to increase the demand for products. Previously, the system was using production schedule 1. Now we'll switch to production schedule 2. By running the simulation again, I can now test out these new scenarios and compare KPIs. Feeding in extra work increased throughput to 817 finished goods. The simulation shows you instantly where your bottlenecks exist, and it's clear in the simulation that we have a large bottleneck before the winding stations. Let's do some more what-if analysis. An increase in demand means your system is going to struggle, so the obvious thing to change here is the number of winding cells. Let's select these and create additional winding machines. The simulation will now run with double the capacity. Interestingly, by increasing the capacity, we have in fact reduced the throughput. There could be a number of different reasons for this happening. If I look at my KPI dashboard in the Results Manager, I can see that the winders are nearly 100% utilized. What would happen if we changed the number of winders? We will recruit another member of staff on that shift to see. The throughput has now increased to 839. However, we have shifted a bottleneck to the oven area. So did we actually require the extra winding machines? These could have cost around $1 million per machine, a potentially large investment. Let's take them out. This is an example of cost avoidance and strategically placing resources within your system. We have managed to maintain the throughput level, so we actually didn't need those extra winding machines. We could have bought them and spent $3 million, but by using the simulation, we can see that we don't need to. By using the simulation, we were able to make the most cost-effective decision to drive the throughput of our assembly line, and that decision was to employ an additional member of staff at our winding area. This is just one major benefit about testing your what-if scenarios within simulation before implementation in your real-life system. That was a simple introduction on how you might use a manufacturing simulation to quickly experiment with different scenarios, allowing for data-backed decisions. Check out more of our videos for further introductions, or contact us if you would like to see something more complex or specific to your own application. Speak to us and learn why so many process improvers in manufacturing choose SIMUL8 for rapid, accurate system modeling.